Okay, hello you IM3ers. I hope you're having a good long weekend. We've got a nice little section here on functions. In fact, our whole chapter is on functions. You've done this before in IM1 and IM2, but if not, it's good to start at the foundation and build up the key concepts as we're doing now in section 2-1. So a function is simply considered to be a mapping or a relation that matches one unique output for every input. So an example of this to remember would be people and height. Each person has one unique height at any given instance. You cannot have two different heights for a person, but many people can have the same height. Many different people can be 6 foot high, but one person cannot have a different height. Okay, so now we got some key terms from this chapter, and two to start with are actually domain and range. Again, you should have done these before, but to review, the domain is your allowed inputs, the control variable for which you have defined parameters. So allowed inputs, okay, that's usually your x's. That's what you're plugging in, okay? And these are called your control variables because you have control over them. You're choosing what variables you're plugging in. Okay, so that's your control variable. All right. Then the range is going to be the resulting output. Okay, and so sometimes you get just a very boring, constant output. Whatever you put in, what might come out would be a constant number. But sometimes it fluctuates wildly, and you get a lot of different outputs. Okay, so this is called the dependent variable. And a lot of you guys have done this very thoroughly in the Pingree Science Department. Okay, graphs are always the x's are your control variable, and the vertical axis will be your dependent variable. Okay, the control variable is also called the independent variable. All right, well, when you make a graph can be something that, to be a function, it has to pass what maybe you learned before is called your pencil test or your vertical line test. That if this is your x-axis and this is your y-axis, that you can hold a vertical line or your pencil extending infinitely, and imagine as it sweeps across, does it only intersect this function, this line, this graph in only one place. If you can hold a horizontal line and do the same thing and it passes a horizontal line test, then it's called one-to-one. And so here the function is one-to-one, 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 but here it's getting questionable. All right, and here if it hits in more than one place, that's where it loses its one-to-oneness and would be then called many-to-one because it'll have two or more outputs there. That are repeated for different inputs. Okay, so there are some key terms. Okay, we'll play a little game here called Spot the Function. Okay, you can pause this and then consider each one of these, and we'll go over whether or not it's a function. All right. Okay, you've paused it now and you've asked yourself, do these pass the vertical line test? So as I sweep my pencil or my pen across here, it looks like yes, that passes that vertical line pencil test. So A is a function. Now with the arrows, we sort of implies it goes on, and we don't know if it's doing some crazy loops in either end of it, but as it looks like right now, it is a function. How about this one? As I sweep this along, right here at that moment that it gets to the end of this first segment, it appears to line up with that, and you might think that it does not pass the vertical line test. But if you look carefully, this is open, whereas this is closed. So at the instant it gets to this vertical line here, it jumps up to this function, and the same is supposed to be true here. Okay, so this is called a step function, and it is indeed a function because it passes the vertical line test. If, however, that was filled in, then it would fail at that instant because this function would exist at 2 points. All right. This one clearly does not pass the vertical line test, so no sideways parabolas allowed. and take a second to consider this. Is this even a function? It's just a list of ordered pairs. Well, this is very much allowed in mathematical notation. We're simply pairing this output, that dependent variable, with that input. And it's going 1, 3, 2, 3, 3, 3, 4, 3. And you see this number repeating, and you might think that it's not allowed because we use that term unique, and 3's are not unique. But remember, it's the x's that have to be unique. So if we made a little graph of this, we would be going over 1 and up to 3, and then over 2 and up to 3, and over 3 and up to 3, and 4 and over 3. And so if anything, it implies a horizontal line, even though we're just given those points. But the vertical line test here certainly is okay. So this one is A-okay. This one, however, appears to start off all right. It's going 1, 3, 2, 4, 3, 5, 4, 6. But then here's where we get to the major problem. That 1 is repeated, but the 3 and the 7 are different outputs. All right? If this had been a 3, that would be all right, because we'd simply be measuring that person and getting the same height that they should have. It's okay to repeat a data point, but it's not okay to have a different output for that unique one input. All right? Okay, here's another little review of your understanding. It says state the domain and range for A, B, and C. Well, I've given you the function in A. It's a quadratic, so it results in a parabola. Okay, this is definitely a function, passes that vertical line test. What are your allowed inputs for the domain? Well, you'd say that the domain can be any x. There's no value of x that I can plug in there that's going to violate any of our rules of mathematics. So I can put in simply all real numbers. And this is a little abbreviation that mathematicians use for all real numbers. Anything on the number line can be part of the domain. Now my range are my resulting outputs, and I can get anything from the x-axis on up, but you'll see I'll never get a negative value for my output, my f of x. So I would say it's going to be all reals, but then I would add that it has to be true that f of x is going to be greater than or equal to 0 at all times. All right, so that's the way we can note the domain and range. So why don't you pause the camera for a second and consider this one. Maybe that's similar, but maybe it isn't. Okay, if you're good and you paused it and you thought about it, you'd say, well, if I were to start plugging in x values, I can plug in 1, because 1 plus 3 would give me 4, and I can take the square root of that and I'd get 2, so I could go over 1 and up 2. I can plug in x values, but when I get negative x's and I get to negative 3 here for x, 1, 2, 3, it becomes 0. And I can take the square root of 0, it's 0. But I can't put in negative 4 or negative 5 or negative anything below actually negative 3. So this is a square root function, and it goes like that. And I cannot have any x values. And we can understand that this is implied and just simply state the exception. In this case, x must be greater than or equal to negative 3. The range then is going to be the same as above. It can be negative, it can be 0, but then it can be anything above 0. So f of x is going to be greater than or equal to 0. Okay. Now I'd like you to look at page 69 and take a look at that function there, the stopping distance based on the speed of a car, and ask yourself what would be the domain and range of that. Okay, I'll show you the clip. Okay, you're back, you've seen the clip. Now the domain, in this case, this is the real world, all right? So this is your speed of a car. Well, the speed of a car, if you want to call it s, has got to be greater than or equal to 0. You can't go negative speed. And then we're going to assume that you're a law-abiding citizen, and I think the maximum speed in this speed limit in this country would be about 75. If you're talking about the German Autobahn, maybe you could go 175, I don't know. But you know that the domain, your allowed inputs, can't go up to like 1,000 miles an hour. For your resulting stopping distances then, you can't have a negative stopping distance. So if we call this distance as a function of s or something like that, then that's going to be less than, I don't know, for 75, it may be like 500 feet or something like that, depending on the speed that we do plug in. But this is the approximate range you're going to get.